So let's look at some from Friday, page 136, 25 to 33. Let's see, what are those about? Find the derivative of those functions. Oh, those involve not just chain rule, but either product or quotient. Yeah.
Too many steps.
Too many steps is right. Let's see, 25 will be product. 27 is pretty similar, except it's quotient. 29 is chain rule and then quotient rule. Same with 31. Let's do 27 and 33. Hit a little bit of everything. So y equals x over. I'm going to rewrite this because I don't like square roots. Because I can't really take the derivative of a square root. So I'm going to rewrite it with a power, because power I can handle. So what's maybe the first rule you notice that we'll have to use on 27? Quotient rule, because we got division going on. So let's call the top one F and the bottom one G. So we need F prime and G prime. And then we'll put it all together using the quotient rule. Well, F prime's easy. G prime. Okay, so G prime, finding the derivative of just trying to cover that up so I can only focus on one thing at a time. Derivative of the bottom is going to be a chain rule type thing, because I've got an outside piece and an inside piece. So we'll peel the layer off first. We got something to the 1/2. So that means 1/2 times the something to the negative 1/2. Right, one derivative at a time. Now the something doesn't change. Right, as you're taking the wrapper off the blow pop, you're not messing with the inside of the blow pop. So we took the wrapper off. Now we'll mess with the inside. The derivative of x squared plus 1, what's that? 2x. And so we're chaining these things together. That's why it's called the chain rule. I guess we should probably clean up G prime before we go further. The 2's will cancel. The x is left in top. Square root of x squared plus 1 is in the bottom. And now, big picture, we were doing a quotient rule, so we got to put all these together. So GF prime minus FG prime. So the x's will multiply. All over G squared. Now that's a free response safe stop, but there's no way that's the back of the book answer. There's going to be some more algebra to go here. This looks a little funny that I have one of these as to the 1/2 and one as a square root. It's like that's the same thing. So I'm going to rewrite this first one as a square root. And then the bottom, this is actually kind of nice because the square and the square root cancel each other out. And I'm left with x squared plus 1. By the way, we're done with calculus, right? Now this is all algebra stuff. So maybe I should have. There's my safe stop. No more calculus after that, but algebra to go. I would like to keep it, change it, flip it to kind of combine all this stuff. But before I do that, I need one numerator. So I need to be able to actually subtract those. So in order to subtract fractions, I need a common denominator. So I'm going to multiply top and bottom by square root x squared plus 1. Now they both have the same denominator. So x squared plus 1, because square root multiplies or cancels each other out, minus x squared all over square root x squared plus 1, and then all of that over x squared plus 1. What a lovely little problem this is becoming. X squareds cancel out. And then I'm going to keep it, change it, flip it. So there's the keep it part. Change it to multiplication. Flip the denominator. And then I guess some people would stop there. Other people would hopefully recognize that x squared plus 1 to the 1/2 is the same as the square root. And that one's x squared plus 1 to the 1. So I can add those together, or add the exponents together, and get x squared plus 1 to the 3/2. And my guess is that's the back of the book answer right there. So, a lot of calculus, quotient rule and chain rule, and then a lot of algebra. So yeah, I can see why 27 would be a what's going on there problem. Let's look at 33. F of x equals x squared plus 3 to the 5th plus x all squared. That's lovely as well. So what's the first rule you're thinking about when you see that? Okay, chain rule. And what will we handle first? Because I got an x squared, I got a 5th, I got a 2. Yeah, this 2. So I've got something squared. So again, work from the outside in, just like you did the blow pop, one layer at a time. So f prime. First thing we'll do is take care of that guy. So the 2 comes down front. We decrease the power by 1. The inside stuff stays the same. Now we need to chain that together with the derivative of the inside of that stuff. So here's another chain rule. X squared plus 3 to the 5th. I got something to the 5th. So I need to change that to 5 times something to the 4th. Don't change the inside. One rule at a time. But then chain that. Derivative of x squared is 2x. And then this one's, I guess, tricky because don't forget about this plus x out there. So plus 1. There's your safe stop. Or if you wanted to find, if it said, it didn't, it just said find the derivative. But if it said find the slope at 1 or at 0, then you could plug in right there. You don't have to worry about simplifying. Just plug it in and see what you get. But I suspect the book would go further. I'm not sure what else we could really do here. Because I guess I could combine the 5 and the 2x. That's about it. Because I don't think there's anything I can factor out. So there wasn't a whole lot between the safe stop and the multiple choice answer there. All I did was combine those two things. But that was a good one because that was a multiple chains. Because you did this first, and then this second. No, this second, and then the inside of that third. So there was like 3 chain links on that one. Yes, no? Still need more practice? Yes. Again, nothing new today, really, nothing new tomorrow. So even if it's like a little bit fuzzy, hopefully by the time we hit Thursday, you'll be okay. Let's do something from 65 to 71. Anybody got a preference out of that group?
What was 71?
Uh-oh, did that? You shouldn't have to have done 71, because we don't know how to do that one yet. $65, $67, $69? Okay, looks like quotient rule right away, because we're dividing. Oop, I switched it to X on the fly. The question, though, find and evaluate the derivative of the function at the given point. Okay, so this is kind of the same thing we just did, except we want to plug in 0, -2 to get to get a specific slope at that point. So this one doesn't really even have chain rule in it. That's just straightforward quotient rule. Derivative of the top is 3. Derivative of the bottom is 1. Oh, I should be careful. The function's called f, and then I'm calling the top f. That's okay as long as you keep it straight in the end. Like, it asks for f prime. F prime is at 3. You know that. F prime is going to be the quotient rule of this. But I'm used to using f and g for top and bottom. So this is a little bit not quite okay to do this. F is this, but f is the top. But as long as you can keep it straight and end up at the right place at the end, you're okay. I could say that the black f is this whole thing, but the red f is just the top. That's how I'm keeping it straight. Alright, so gf prime minus fg prime. Careful with the minus sign, make sure it gets distributed to everybody. All over g squared. Now I have a couple of options here. I want to evaluate this at 0. So I can clean up the algebra with the x in there first and like simplify that and get a better answer, or I can just plug in 0 and start to simplify. It's kind of the same work, right? I've got to simplify. It's just, do I want to simplify with x's, or do I want to simplify with a 0 in there? What's your preference? Do you want to do algebra first or 0 first? I think most students would pick 0. I think that's probably the best choice. Especially since it's 0, math makes it easy. Let's see, 3 times -1 would be -3, minus 3 times 0 plus 2 would be 2, all over -1 squared would be 1, so -5. So the slope of f at 0 is -5. The instantaneous rate of change of f at 0 is -5. The slope of the tangent line at f is -5. The derivative of f at 0 is -5. Again, just trying to remind you of all those different words we can say that all mean the same thing. And then if we wanted to, we could write a tangent line. It didn't ask us to, but usually it would. It's an easy last step. There's the tangent line. There's our slope. And there's x and y. Again, it didn't ask us to do that, but a lot of times it asks for that last step of a tangent line.